In this series of videos I'm attempting to repair this Hazeltine 2000 smart terminal. In the video so far in this series I've been through the basic chassis, I've been through the CRT monitor, had to make a few repairs, and what I then did was start working my way through the PCBs. And I started at the clock, checked the clock was running, looked for the phase generator, and then we looked at the B13 board to make sure all the vertical drive signals were being generated. These are not just the drive signals for the CRT, these are also the signals required to drive the overall system. And then we moved on to the A8 board, which generates the horizontal drive. Once we'd done that, the next thing I could do was effectively connect the monitor, which is why I moved on to the CRT at that point. And so now that we have the horizontal and vertical drive signals going, I was able to hook up the monitor, and we can get a raster. I showed that in the previous video, but I didn't have the video output card fitted, so I was using a signal generator to effectively test the monitor. I left it running for several hours and that's working fine. So the next phase is to add more cards. So as I mentioned in a previous video, the early cards you can kind of test one at a time, but once you get beyond a certain point you need to start adding multiple cards. I've had to add 8 more cards. So the approach I'm taking here is we've got the clock running, we've got the CRT up and running with a raster showing, and so the next thing is to start feeding it some data. And if we work our way back, we can see that we need the character generator. This really is just a series of shift registers that shift data out in a serial form to the monitor based on the line scan position. And that also means that we also need the line counter, the cursor address logic, the refresh logic, and the internal program counter for this to work. That's why I need to fit multiple cards. So I also got the keyboard plugged in. I don't know if this works yet. I'll just have it plugged in so I can access the reset switch that's on the case for this. I haven't tested the rest of the keyboard, although I have cleaned it. We'll come back to the keyboard later, but just bear in mind the only reason it's plugged in is so I can access the hardwired reset key. So as I said, I had to fit 8 more boards, and I was going through the exact process I've shown before, so I won't show it in the video. It's quite long-winded, but all I was really doing was getting the cards one at a time, putting them onto the risers, going through and testing the various functions. So there were a series of counters for the cursor position, coincidence comparators for generating the cursor so that it knows where on the screen to put the cursor. So if you're not familiar with how these work, they generate an image by, of course, producing a raster on the tube, and that's just a series of lines that are scanned left to right, top to bottom across the face of the tube. As that scan progresses, then the X and Y coordinate that the scan location represents is used to determine which particular character and which part of a particular character to feed out to the tube. And by doing that, it can generate characters on the screen on a kind of pixel by pixel basis. But of course, for all that to work, the timing of all the individual steps has to be correct. So it has to be able to feed the data out into the data stream, to the video, and also this is an interlaced display, so it has to alternate between the 2 sets of data in order to generate characters on the screen, and all that has to be kind of choreographed using various timers. So that's the boards I was fitting. Like I said, I was going through each board, plugging them in, testing them, removing them, and then plugging in the next one. So the boards I've had to fit are the X coordinate count, that's for the cursor X coordinate, Y coordinate count, the X coincidence, Y coincidence, the line counter, video output card, that's the card that mixes the various data streams, and that's what's fed out to the tube, the program counter, and the data register. Although I don't have the memory fitted, there's no RAM in this yet, I have to fit the data memory, otherwise the inputs to the video are floating and it won't display anything on the tube at all. So now that we've got those cards fitted, we effectively have this block in place, this in place, this. We don't have this yet, this is not fitted, but we do have the internal counter and or some of the decision logic. We haven't got all of it yet. But we should have enough to display something on the screen. I did find 2 faulty ICs while I was working my way through those boards, which is not too bad, and replaced those. And as far as I could tell, there were no other faults. So this should now allow us to actually output something onto the CRT. And I don't want to go any further than this until we've got that working, because there would be no point if we can't output anything using this arrangement. Then putting more cards in is just going to confuse the issue and we'll be chasing ourselves in circles. So now I've got all the cards fitted, we'll try and power this up. I haven't tried this yet, so I'm not quite sure what's going to happen. I don't think there'll be any magic smoke being released. I have already tested all the cards individually, but this is the first time they've all been plugged in together. So we'll try and power this up. We'll wait to see if the tube warms up and if anything appears. So nothing so far. Just take a few seconds, of course, for the tube to warm up and something is appearing. I'll also move the camera across so you can see this more clearly. Okay, so as you can see, there is a character being repeated on the entire area of the screen. And the character being generated it's just really a function of the fact that the data lines at some point are just floating, and that's the arrangement will lead to a particular value. The important thing here is that it's a valid character and it's clear. Slightly out of focus, but I haven't adjusted the focus yet, and I'm just going to count these ones. And that's 27 lines. It's going to count across. Okay, we're getting 74 characters across, 27 lines, which is exactly what it should be. Okay, so this is quite significant because it means quite a lot of the system is now working as far as the display generation is concerned. It's showing that the data shift out, these serial shifters are working. The X and Y coordinate counters are working. The data register is working. The interlaced timing and switching is working because the character is complete. There's no overlapping or gaps that you would get if that wasn't working. The logic control for the display is working, which is quite complex. The refresh logic's working, the main clocks and the timing is correct. This is all nice and stable, properly spaced, so it's looking good there. The video mixer output is working. There's no cursor yet, but then I wasn't expecting there to be. We'll look at that next. And the interface logic and control circuits and the reset are all working, so that's a lot of the system as far as the display generation is working. But what I want to do now is see if we can get a cursor to be displayed on the screen, and that will show that the logic for the cursor control is working. I don't know where it will appear. It will just be whatever the random reset position is, because we don't have the cursor and keyboard control logic in here yet, but we should still be able to get a cursor to appear. To do that, we need to fit another card, so I'll just grab that card. Okay, which is this card. This is card A16, and if we fit this and it works, then we should get a cursor appearing. So I'm going to put this into risers. I'm going to give it the usual test. I have incidentally cleaned all these cards, so they had a thick coat of dirt on them, but I've given them all a good clean. And as I say, I'll do a static test on this, then I'll do a dynamic initial test, plug it into the risers, make sure it seems to be doing what it's supposed to, and then we'll get back on camera and see if this gives us a cursor. I tested that card and it seems to be working fine. I can't find any faults with it, so we'll power the system back up. We should find somewhere that there is a cursor being generated. Now, in theory, it should reset to the top left-hand corner, but because the cursor control logic and keyboard logic is not yet fitted, that reset won't work, so the cursor could appear anywhere, but it should still be a valid cursor being displayed somewhere. So we'll power this back up. Wait for the tube to warm up. And here it comes. And looking around, we do indeed have a cursor. That's this short bar here. So the cursor is now being generated. Again, that's a very good sign. It means that the coincidence timers, the coincidence counters are working. It doesn't mean they're working correctly. Maybe this should be up here or somewhere else, but at least it indicates that the system is capable of generating and mixing the incoming data streams and correctly displaying those on the CRT. Okay, so that's quite a good sign. It means we're getting some progress here, and the reason I'm taking this approach and doing things in this order is because if we don't have anything displayed on the monitor, it's very difficult for us to make any positive progress, because if the screen's blank we don't really know what's going on in the electronics, and so it's just far easier going through this route where we have kind of visual feedback of how we're progressing. Doesn't look right, of course, but because it's all the same character, but we don't have RAM fitted, we don't have the RAM control fitted, and that's what we'll do next. I'm just going to move the cameras so I can just describe where the RAM sits and how it's arranged on this particular machine. Okay, so you notice on this machine we've got a big gap down here and another one in the first rack, and if you look inside, I won't move the camera, but if you look inside there are no actual sockets there other than two in these two positions. The rest are empty, and the extra height on the rack is for the A version of this terminal, which used core memory. This particular terminal is a B version and it uses MOS memory. And with the core memory, if you have one with core memory, then what you will have are some extra cards in here. So for example, you'll, in addition to the cards we have, you'll have cards A1, A2, A4, A5, B1, 2, 3, 4, 6, 7 and 8 fitted. So it's a lot of cards for the core memory. Core memory is quite a complex type of memory, requires a lot of electronics to drive it. In the version we have here, there's only 3 cards that are required, and 2 of those are the same cards or similar cards to those used for the core memory. So we only need the A5 card, which is the data register, and we already have that fitted because we needed that for the display to work at all. We then have memory control, and then we have the memory card itself, and that's the only cards we need for the memory system on this version of the terminal. So the next card I'm going to look at is B7. B7 is the memory control card. This is what controls data in and out of the MOS memory card. If I fit this and I don't fit the memory card, in theory we should end up with a blank screen, because this will be trying to get data out of the memory card. At the moment the system's trying to read data from the memory card, but without this here, what's being returned is just whatever the floating pin values are, which is why we're getting the same character in all locations on the screen. When we fit this and not the memory card, it's going to, in theory, return a blank character for every location. So I'll fit this, well, I'll test it first. I'm going to do the usual. I'll put it into risers, do the static testing, make sure there are no shorts, do some basic dynamic testing. I can't do much testing with this without the system running, so I won't be doing too much, but then I will fit it into the rack, and we'll see if the screen goes blank, which would actually be a good sign. Incidentally, if you're wondering how I'm testing this with the rest of the system up, I have the second chassis further along the bench, and I'm using that chassis to test the cards before I plug them into this one. I don't want to risk the cards I already have in here, so I can plug a single card into that chassis and just use it really as a test jig, which is what I'm doing at the moment. So I'll get this tested, and all being well, I'll get it fitted and we'll see what the result is. Okay, I have the B7 card fitted. I tested it and I did actually find a fault with it. The output of one of the ICs wasn't changing state when it should have done, so I've replaced that IC, and that is one of the advantages of testing the system like this, is that the maximum number of ICs we got on any particular card is only 20. So as long as we know what particular card a fault is on, it's quite easy to track it down. But there are about 30 cards or so in this machine, and if we don't know which particular card the fault is on, it could be very difficult finding out where that fault is. But that took me probably no more than 5 minutes to locate the fault, replace the IC, and now in theory that card should be working, but we don't know if the entire system's working. Almost certainly there will be other faults in this that will come to light as we add more to it, but going through this process, at least he's going to get something on the display that we can use as part of our diagnostic and fault finding procedure. Okay, so I'll get this powered up. Now in theory we should get a blank screen. If anything comes on here, if it's garbage or if it's all lit up, then we've still got a fault with that card. But we'll see what it does. Give it a few seconds to warm up. And we've got the cursor, which is a good sign. I'll just move the camera across so you can see the screen a bit better. So we've got the cursor showing. It's actually not in the same location it was before, which is actually quite a good sign. It means that each time we reset this, we're getting kind of a random count in the cursor coincidence counters. And it does mean that they are not just fixed all the time. Okay, so that's good. So the rest of the screen is blank. I can't see any of the rogue characters anywhere. That's exactly what we should be getting. And so what we can do now is fit the memory card. Now I have popped all these memory chips out of the card and tested them. There is a fault with one of them, but it should still allow us to display something on the screen. And I'll get this fitted and hopefully we'll get something on the screen. Now in theory it should just be garbage. It should be whatever characters are in this memory when we power it up. But we'll see, because we don't have any way to control data input to the card yet. All we're doing is trying to read data out of the card, and so in theory we should get garbage, but it should be character garbage. That is, it should be valid characters. If it's just nonsense and kind of scrambled characters, then we know we've got a fault somewhere. But if it's just random characters, then we know that a lot of the system's working and the values represented in the memory are being properly converted into characters. So I'll get this fitted. As I say, I've tested the RAM chips. I'm not going to try and test this. I've obviously tested the card for shorts, but I'm not going to try and test this plugging it into the other chassis. There's no way really for me to test the entire card, but I have tested the individual chips, so we'll see what we get. Okay, I've got the card plugged in. I'm going to try and power the system back up. Fingers crossed we get some nonsense displayed on the screen. Just wait for the tube to warm up. And we are indeed getting garbage on the screen, so that's a very good sign. It means that the system does appear to be working fairly well, and we are still getting the cursor displayed as well. So everything's been mixed. We're getting data coming out of the RAM. I don't know yet if it's all coming out properly, whether or not, for example, this should be an uppercase B in this location, but that will be now much easier for us to backtrace and find any faults. Now that something is on the screen, we can start doing more meaningful testing if we need to. If I try pressing the reset key on the keyboard, you can't see it, but I'm going to press the reset key, the display should go off, which it does. Release the key, and as you can see, it's responding the way it should do. I'm just going to try and cycle the power. Give it a few seconds for the power supplies to die down. Power it back up and see if we get a different pattern on the display, which we have. So again, that's quite good. It means that the information we're seeing on here is it's kind of random information in the RAM. It's not just fixed values because there's a hard fault somewhere. There may be a fault, but at least we are getting data that can change, which is a good sign. It means that chances are, if we change the contents of the RAM, it's going to change what is being displayed on the screen. You can see probably that the screen is offset. This is what the little tabbed adjusters are for on the neck of the tube. They allow you to center the image. So I'll do that. I'll do it off camera. I've got to rotate the machine, and then you just turn the tabs around until the image is centered. It's all the way off to the left at the moment, and I'll get it centered for the start of the next video. But that's it for this video. We've made a lot of progress. We can now read data out of the RAM, all the timers, the interlacing, the serial shift out onto the screen, and the cursor generation. All that is working. The next thing we need to start looking at is putting in place the keyboard control logic and see if we can actually start getting some information from the keyboard. Now, as ever with a terminal like this, we can't just put in the keyboard logic alone. We will need to put in the baud rate generator, the serial control, because the way these terminals work is the keyboard is effectively part of the serial interface. It just represents one of the data sources for serial data, so that data does go through the serial channel, so we do need that logic in place. But having said that, this is looking quite good. We are now getting to the point where we should start being able to interact with this to do some more meaningful tests. What I'm going to do before the next video is, as ever, just leave it running for an hour, make sure no faults develop. And I like to do that. What I don't want to do is just rush through this and have a fault develop in a card I've already fitted, because it's very easy then to get misled, or it may appear that the latest card you've added is not working, when in fact what's happened is a card fitted previously is the one that's at fault. Okay, so that's it for this video. If you want to see any specific testing with this, then let me know, but we are making good progress.